Okay, good evening, gentlemen. So I'm recording. I just put a record there. Okay, I'm not sure. I think it's okay. But it's right. Okay. So today is our tutorial session. ESIS 28 November, Friday. Okay. So what I was just trying to share earlier was, you all should be able to be quite familiar with your handheld calculator. Okay, so that you are able to easily convert. Okay, I would say easily. Things like this, right? Okay, converting the binary, okay, into things like decimal, okay, and then vice versa, and that means you also can convert the other way around. Binary numbers, given any binary numbers, your calculator should be capable to convert these to the decimal equivalent, but that depends on the operator. The operator must know how to key in. Okay, now, okay, now likewise, okay, if I give you any decimal number, you should be able to convert this into a binary format. Okay, but I need to tell you how many bits. Okay, in this case, I have an 8-bit system. For example, 8 bits. Is that okay? So that's quite important. Okay, for this course. Okay, so that's the first thing first. Any question? You all try to ask your friend if you're not sure. Maybe you all have the same model, right? You all can discuss. If not, of course, the recommendation is to look at the menu, but menu sometimes is very long to read.
Throw it.
Throw it. But I think you can download online. You just Google the model of the calculator, you can get the operating menu. Okay, so this one is quite important. So please make sure you are able to do this. Okay, so in that case, we can proceed. Let's proceed. Okay. Now, because of the short span of time, I want to maximize the time for you all, so that you all can benefit most out of the tutorial. Okay, so first thing first, if we look at, I think we still owe you an answer, right? So for your tutorial question 6, right? Tutorial 2. Okay, so you all have the answer, right? Do you have any comments on the answers? You all have the answers, right? Which I have printed for you all, right? The answer. Any comment? Have you had a look? So basically, they're saying that the question is a greenhouse farm, right? You read the question, the greenhouse or green farm. So you need to determine how many sensors, right? So if I look at the answer, right? I look at the solution. You have the solution, right? You look at the solution, right? So what it says is that you need 4 sunlight sensor, right? Actually, it's light sensor, light detection sensor. How about pH? How many do we need? Can check. Can you all see how many pH? Question 6. If you have not looked at the question, I'm jumping straight into the solution. Question 6. Okay, so basically the answer says that you need 3 pH sensor, right? 3.
Any of the 3?
Yes, any of the 3. For moisture, you need 4 sensor. Okay. Then also you need the digital output, right? DO, right? They call digital output. Digital output. Why we need digital output? You want to control the motor, right? Because you need to use the motor for some control, right? So I say DO. DO stands for digital output. Okay, digital output. High or low, right? If it's a digital output, it could be 0 volt or 5 volts. Okay, your digital output. Usually 0 volt or 5 volts. Yeah, 0 or 5. How about your AI? What does AI stand for? AI. Analog input. Analog input means you are taking in, say, some voltage or some current, right? It's possible, right? So it's called the analog input output. Okay, so you have DO. Then you also need dispenser, right? Yeah, the alkaline dispenser, right? DO, right? So the solutions provides you, you can use a 5-watt dispenser, but you need about 6 of them. 6 of them. Look at the solution, and then look at the question as well. Right? Okay, so for the pumps, you need 4 pumps. Okay, 4 pumps in that question. Okay, 4 pumps. Now for part 2, right, of the question 6, so basically no DAQ, no, right, the answer is no, and then DAQ card supplies a maximum of 20 milliampere. Usually the DAQ card cannot supply a lot of current one. Cannot. Usually the one is output to drive another circuit. You know what I mean? Your output for your electronics cannot output a lot of current to drive high power. So you have the low voltage and then the high power circuit. I mean standard in the industry, right? Okay, erase this. So very common, right? When you do some kind of circuit, okay, usually, right, you have what we call the control circuit. Okay, so maybe it's what we call a control circuit. Control circuits are basically electronics. Usually electronics, maybe like DAQ, okay, things like DAQ and so on. But the output is very small. The output, these are the electronics, right? Because electronics, so you talk about electronics, understood things like, you output things like 0 volt to 5 volts, kind of thing, you know what I mean? Simple electronic circuits, output very low or maybe very low current, maybe in milliampere and so on, right? But this electronic, right, will be used to drive something. Okay, and usually, right, this because the voltages are too low, you can't drive AC, right? Can you? Cannot. If you have AC motor, right? You cannot. If this is an motor, right? If this is an induction motor or something, you cannot drive it because this one running AC, AC source. So what you do is normally you will either you have the signal conditioning. This one will be my topic, which I'll be talking in topic 5. But just share with you. Okay, so this one you need to signal conditioning. Usually, signal conditioning means you have to do something to the signal condition because it's too low. So what you need to do usually you have an amplifier. You know what I'm saying? You need to have this. You all may have seen this symbol before. It's an op-amp, right? For example, okay, there are many different types of circuits. But op-amp is what you actually will amplify the signal first. Okay, before maybe you drive a relay, maybe it's a DC or AC relay kind of thing. Okay, then you will control your load. Standard, I think your work in the industry, so your loads are maybe AC loads, okay, high power or some stuff. So depends. Okay, so you have the control circuits. Okay, then you have signal conditioning, usually amplifier. Preamp or amplifier or instrumentation amplifier. You amplify the signal, but then you're able to maybe switch a relay, AC relay, DC relay, or you do PWM, pulse width modulation. Maybe later, PWM stands for pulse width modulation. One can control the speed. Okay, so this is a general kind of setup, controller setup. Electronics, signal conditioning, okay, can be preamp or amplifier, power amp, power circuit, power amplifier circuit, then after that go to the load. Okay, this is general. Okay, so for the case of the question, right, your DAQ card cannot supply very high current, definitely. Okay, but you need maximum 20 milliamp, right? So you cannot drive the valve dispenser nor even the motor because your motor needs very high current. Because it's a load, high load, greater than 10 ampere. Right? Usually, even things like the pump, AC pump, those kind of things, you cannot, not enough to drive. So what you need to do, if you look at the next page of my solution, you have a copy of this, I hope. The solution, the one you have, right? The same thing is what I have. Okay, so what you do is this over here, right? It actually shows you some simple circuit configuration. So you can see that what it has drawn, right? If I erase this portion. Okay, what you can see on that diagram, if you look carefully, okay, what they are showing you is DAQ. Okay, DAQ. Something like the one that we did in the lab. Right? Because the output of this is maybe 0 volt to 5 volts. Very small. 0 to 5. Okay, the kind of range. Yes, it could be current as well. Current So basically what you can do is that you can drive a transistor. Transistor, right? You know transistor, right? Okay, maybe it's a TP41, let's say, for example. Okay, so then I can drive a motor. Oh, quite common. These are quite common, even for project. Those projects. Okay, so maybe your this motor, maybe 24 volt. 24 volt quite standard. Not like car battery 24 volt. Okay, so maybe you drive it. But imagine this one is very small current only. Very small, right? Maybe only about 10 ohm, for example. Could be current loop. Okay, you can drive a 24 volt supply. Maybe, I don't know, 5 amps, 5 to 7 amps easily, right? 5 ampere very easily. So you can design something like this, very good. Okay, so this is a motor. Okay, so for the, you can look at it, the part 1 it says it's the motor, right? This is the motor. Yeah, this is an amp. Okay, now then of course the other one they say you can do things like another circuit. Show you also another circuit here. We just show you on the video here. Okay, so this is the same thing. Okay, so basically the other circuit is a dispenser, right? If you look at it. Yeah, okay, a dispenser. So a dispenser could be just a simple on-off using a simple relay. Can you look at it on the simple relay circuit, just to control the dispensing circuit. Or even a pump. Pump also the same thing. Pump and motor very same circuit. But just that you replace it with a pump. You know what's a pump, right? I'm sure. Pump for those water kind of thing. You can pump up water. Okay. Yep. Any question? I think the next part, the one part 4, the one is the tricky part. That one you're quite scared one. Ask you to write a C code, right? Can you all see that one? Yeah. This one is important, I tell you first, because I tell you why. I was looking at the exam question. Better tell you first, PMU. Okay, one question. Mr. Chan said one has something like some small. You have to write some small C code. You know what I mean? The C code. You want to learn. I want the C code. But it's quite important. You need to know a bit. Yeah, you learn can remember. Very blur. The C. Okay, the C code. So he's asking you to you have to write some C code, right? Inside that part. Correct. The question. What did they say? Can you read for me? Part 4. What did they ask?
For pH sensor, determine the stability of to control the alkaline dispenser.
Alkaline dispenser, right? Yeah. How many times? The alkaline dispenser. How to?
6 alkaline dispenser.
Your 6 times, right? Your 5 volt. The 5 watt dispenser, right?
Yeah,
so how to do?
Dispenser.
If the pH is how much, then you will activate. Less than, right? So basically, what I can see, okay. So for this is in C code, but you all have to memorize this one. You see, if they ask you, put the same thing, almost the same, similar kind of thing. So you have to remember this one. If pH, right? This one no choice, gentlemen. This one no choice really. This one you got to at least memorize, know the syntax. Not syntax. Syntax means like this. For x equals to this, then.
No, if for x1 to 3 and you got 6 dispenser.
So 3 cannot, right? 3 should be 6, right?
Yeah. Say 1 to 6, okay, we understand. But 1 to 3, like you know, like
something missing. I think should be 6. From the way I see it, should be 6.
Should be 6. It's 1 to 6, like 6 alkaline dispenser.
Yeah. You all change the solution. I think it should be 6. This one change to 6. I think not 3. I think 3 is the whole version. Can you update? Can you change
any of the 3 sensors? Any of the 3 sensors?
Correct. Correct. So it's correct. So not 6. Any of the 3. Okay.
Any of the 3. That means correct. 1 to 3.
Okay. That means don't change it. Correct. So I was thinking that the question may have some changes. Okay, let's take it at 3. Because if you're correct to say that the question is any of the three, right?
Yeah.
It means okay lah, 1 to 3 lah, fine lah. Any of the three mah. So fine. Okay, we stay with that. Okay. So but the pH level, if it's less than, right?
Yeah.
Less than 6.5, then you will enable the dispenser. Yeah. So if pH less than, then you have a then statement. This one no choice, right? Gentlemen, this one really no choice.
Then you will start.
This one you have to memorize the syntax. And no choice.
The dispenser off.
So it's something like that, dispenser on, right?
Yeah.
So this one is like what we call a small subroutine. This one you will call this part. Usually, you know what I mean? When you do it, then you will activate this portion. This line, right, is something like a call a subroutine, a small program. Okay, then else will be the dispenser. Or you look at the solution. Else the dispenser will be switched off.
If the pH is higher, then power is off.
Correct. If it's less, then you will do this. If not, else. Okay, you have an if, then you have an else, right? If you have like something like a case statement and an if, and else, then the dispenser off. Yeah, this one no choice. I tell you honestly, this one is programming. No choice. It's syntax. Yeah, maybe at least 7 marks.
As long as they ask for a strategy, is the C code.
Yeah, C code. If they ask you, I think the exam they will specifically tell you write the C code like program. No choice, confirm. No choice. You have to write. This one no choice. I cannot help you. Because it's a syntax. So you know what I mean? It's like obeying the law, right? Obeying the traffic rule. It's a syntax. No choice. When I see red, I must stop. Then it's understood. You know what I'm saying? So it's a syntax. So you have if, then you have else. The statement must follow. Okay, this one you will minus mark. But if you understand the sequence, I think can do lah. From what I see, is doable. If you understand the question, you must also understand. Okay, for example, if I tell you is 1 to 3, how do you know it's 1 to 3? You must read the question, right? First thing, you must understand the question, know what they are asking.
They say 3 sensor on, then can. Then they have to write it longer to count the sensor.
3 sensor. Correct. Okay.
This one simple.
This is simple, but they will give you simple one. Trust me, they cannot give you because this course is not a software programming course. Simple. This is a for loop, right? For x is 3 times. I think usually it will be 4. You won't be given. You know, there's anything called while loop.
Yes.
The one means do forever. That's called because I also teach programming, but I teach it in different. I do LabVIEW the software. Different. Y'all got in C. Y'all do that. No lah. Don't worry. While means you do forever. This thing will keep looping until maybe a stop condition. Okay, so different. Never mind. Don't worry about that one. Don't worry about it. Follow this one. Okay, follow on this. Okay, then you won't go wrong. Okay. Yep. Okay. Then after that, the same for the part 5. Yes, correct. Okay, so just have a look first. Have a look. I think it will be quite simple. It will be similar. Similar kind of thing in your exam. Okay, write very simple for loops. Basically, it's the for statement. Okay, for x equals to 1 to 4, and you check. The if means you are checking, right? Maybe for info. If means it's a conditional check, right? Okay, if I ask you, if this is this, I do this, right? If else, I will do another thing. Okay, if it rains, I will carry my umbrella. Else, I don't carry my umbrella. Something like that. You know what I'm saying? If it rains, right, I will carry my umbrella. Else, then I don't carry. Because no rain. Correct? So it's like something like that. If and else.